The fourth question that we have is a pretty simple question. If you can analyze and visualize the structure of a body centered cubic lattice. So we have been given that chromium metal crystallizes in BCC lattice and the unit cell length is given to be 287 picometers. We need to find out the atomic radius and the density of chromium. So for solving this, I have already drawn the diagrams of body centered cubic lattice. In a body centered cubic lattice, the atoms are not touching along the H centers. We have these 4 atoms. Below that, we have another atom, single atom, and below that we have another 4 atoms similar to these 4 atoms just below them. Now this can be visualized like these 4 atoms are there as these 4 atoms, then this is the central atom, and on top of them there are another 4 atoms where these atoms are not touching each other, they are just touching the central atom. So to find out the unit cell length, the length of the unit cell, what we do is that we see that, or rather visualize that the atoms are touching along the diagonal, as in this diagram this atom and this atom are touching each other in this fashion, that is this atom and the atom below this atom are touching each other like in a diagonal. So that we need to now find out the length of the diagonal of this cube, which can be easily found out. This length is A, this length is the root 2a, this is root 2a. So therefore this is root 2a, this is a, therefore the length of the diagonal will be equal to root 2a whole square plus a square, that is equal to root over this quantity, that is equal to root 3 times a. So we know that the length of the diagonal is root 3 into a, and that is equal to this length, and that is equal to 4r. Therefore we know that 4r is equal to root 3a. You need not derive this every time, you just remember this formula that for a body centered cubic lattice, root 3a is equal to 4r. So on putting the values over here, we get a is equal to 4 upon root 3 times r, or rather r is equal to root 3 upon 4 into a, that is equal to 287 picometers, that is r is equal to 124.27 picometers. So we get the answer for our first part, that the radius of the atom is coming out to be 124.27 picometers. Now we need to find out the density of chromium. To find out the density in any lattice, we need to find out first how many atoms of the crystal are there inside the lattice. Therefore to find out that, let us first see the contribution of this atom towards this unit cell. As we have already seen, will be 1/8, as similar for all the corner atoms. Therefore the total contribution of these 8 atoms is 1/8 into 8, that is equal to 1, and the contribution of this atom will be 1, therefore 1 plus 1 is equal to 2. Therefore the total number of atoms in this unit cell comes out to be equal to 2. Therefore the density can easily be found out as density of chromium equal to mass present in 1 unit cell upon the volume of 1 unit cell. The mass in 1 unit cell is 2 atoms into the molecular weight of chromium upon, this will be, we will write it in grams, therefore we divide it by Na for finding out the mass of just 2 atoms. This is the mass divided by the volume, that is A cube. Substituting the values over here, we get 2 into 52 upon, the molecular weight of chromium is 52 upon 6.023 into 10 raised to 23 into A cube, that is 287 into 10 raised to minus 10 whole cube. I have converted this into centimeters to find out the answer in gram per ml. This comes out to be equal to 7.30 gram per ml, and this is the final answer for the density of chromium, that is 7.30 gram per ml.